Okay, we'll start with the design of Twitter. We'll start by defining the functional and the non-functional requirements. So what would be the functional requirement, right? When you go onto Twitter, what do you see? I can see that there are users. Okay. And each user has like a timeline. You have your own profile. Okay. And a user can follow follow other users, and other users can follow them. Reply to tweets, retweet. Now we have like privacy of tweets. We have editing of tweets. Okay. Also, I wanted to mention that within the timeline, you see followers plus recommended. So these are like the functional requirements I can think of. Obviously, we can add more, but I have just made a list of the requirements that I think are there in Twitter, and we'll elaborate on a few. So I just wanted to make a list and we'll pick a few and talk about them. Okay, so what about the non-functional requirements? So for the non-functional requirements, it should be scalable, available, and reliable. I feel like this is the same in all the questions. Like we want to design robust systems, okay, which can handle like load and failures. Although this is not a very critical system, so we can have like some leeway on the concurrency issues, but in a gist, this is what we are thinking about. Now let's do some estimations. We know when we go to the thing, a tweet is 140 characters. Okay, and each character takes 1 byte. We can say 140 bytes. Plus we can say some metadata that we could say is like 20 bytes. So each tweet is around 160 bytes. Okay, so let's think about the number of users. So we have, let's say, 2 billion users with, let's say, 1 billion active users. And if you kind of think about how you interact with the Twitter thing, you're mostly reading. Most people read than post. Like people are lurking. Okay, this is something that stands out. So for 1 billion active users, let's say only half of them are posting. Say we can say 0.5 billion tweets per day. So we did some estimations. Let's think about the problem now. Let's think about followers and timeline generation. So what does a timeline look like, right? There are features that I would think about as recent posts by followers, right? So when I have to design this timeline, I need to kind of design the followers and then how would I, and the post table and kind of relate them. Okay, in a very basic exercise, if I was given this, how would I design this, right? You could have a users table where you have the user ID. This is the profile actually, profiles of people, okay, where they have the name, email, password, whatever. Now we have to think about the followers, right? The followers table. How do we build the timeline? We need to know who follows who. A naive or like native or naive approach or like intuition one would be that I have a table which has X and Y such that X follows Y. So you can say follower and user followed, being followed, something like that. And I can say to give like, let's say I do an index on Y. So if I have that index on Y, it will be like this. If I am Shivi, I follow, let's say, Drake. I am Shivi and I follow, let's say, Kesha. Okay, and then someone else comes in, let's say Vishal, and he follows like Green Day. Okay, and then someone else comes in and they follow Drake. Let's say it's Amy. Okay, so now if I have an index on Y, so if I had to find followers of Y, or like who is following Y, it is of like, it is easy. Okay, it is easy because I have an index. Like now if I reverse the question, I say find all people who follow Drake. Because we do not have an index here, it is gonna, we have to go over all of the things and find it. So O of n. Okay, and if you think about this across multiple partitions, across different machines, you can think of how bad this design is. Okay, can we make this better? Is there some way we can make this better, right? So what about, like, we should never be afraid of replicating data. Okay, so what about we create this table like followers, we say Shivi, followers, Shivi follows Drake, Shivi follows Kesha. Okay, and there is a, whenever the user follows someone, they update this, there is a change data capture that, okay, someone has put in some new data, which then goes over Flink, or let's say Spark Streaming, or we can say Flink, which then goes and makes their own database which has that. So now over here would be Drake, Kesha. So the index is here, and in our previous case the index was here. Okay, so now there are two kinds of queries that happen. Find followers of Drake, then I can just look here and get all the followers of Drake. Okay, question, find who does Shivi follow. I can look at this table and answer that question. So I think this is a good model of how we want to store the user's follow versus follower data. Now, let's think about this. Now we have this. Can we try to build the timeline that we were talking about? How can we try to build the timeline? Right? So let's try to build the timeline now. So building the timeline. Okay, so now we can have obviously post table, and will be like post ID by the user, text. Actually, we have not talked about what kind of post can be there, or like what kind of data can the post have, or like what kind of data the post can have. And now that I think about it, it could be like images, videos, which we have not, like we are not handling in this, we are not handling, or we have not talked about. Okay, we're talking about the very basic thing. Maybe we can think about doing like discussing it in the future. Let's concentrate on what we're trying to do. Okay, so now whenever a user comes in, they make a post, they say like one, say Shivi, and she says the weather is beautiful, it's whatever. Okay, and now if I had to make a timeline for Shivi, or like a follow of Shivi, what would I do? So this is this one. This person goes and asks the application, give me my timeline. So what would this do? This would go to Flink and find, because it has in-memory database or in-memory processes, which has the user follower table. It can say look up all the people XYZ follows, get their posts, and build the timeline. So far what have we discussed is a naive way of building the timeline, right? We've discussed that when XYZ, the user, wants to look up their timeline, the app queries the users table, gets all the users that XYZ follows, and then uses those users ID and in the post table to kind of make the timeline. So when we look at this, we can see that when the requests are made for the posts, the data can be distributed across partitions, across disks, and which can add to the latency for the application. And because our application is read heavy, so can we do better, right? Can we optimize this? And from what we discussed earlier, this application is read heavy, right? So one way to optimize this could be using caching, right? So what happens is, let's say we use cache such that each user has their own cache. Okay, and whenever a person, let's say user XYZ, posts something, their caches will be updated. Okay, so the app says, okay, post from XYZ, look up the XYZ cache, add the post, and add it to the database, and add the post to all the followers XYZ followers timeline or caches. Okay, so if XYZ says follows me, so this is my cache, and then uh, this message would also go into my cache. Okay, so just to reiterate, when the user makes a post, the application will look up the followers and post the message or the post to each of the followers cache. So this way what happens is each follower or each user has their own cache from which the timeline is built. And supposedly, say now he has written this and I follow XYZ. So when a user requests that, okay, get me my timeline, the application can just return the cache. Okay, so this improves upon the previous thought process which we had, in which we had to make joins across multiple tables, right? But now think about it. This will work for, let's say, XYZ or me. But think about, let's say, Drake. He has 5 million followers. So would you want the application to go and update 5 million caches? There could be like something happens and there could be discrepancies, and updating 200 versus 500, sorry, 5 million is different, right? So can we improve upon this? Can we think about, okay, should I handle the popular people's posts differently, right? So if someone has 200 followers, you can write to all the caches, but for like 5 million or 1 million followers, things could crash, things could go wrong. Can we like think of another way in which we can make the popular person's posts not be written to like 1 million caches? So let's think about it. We could do a hybrid approach in which, firstly, we need to know the popular people. So we have a table which has all the popular people. A popular person could be anyone who has more than 1 million followers. And similarly to the table, we kind of have a popular cache just to make things look up faster. So whenever Drake or like a popular person posts, right, the app sees that, okay, this person Drake is in the popular cache. So I don't go around and updating all followers cache. I just write this to another cache, which is popular people cache. Okay, so in this way I don't write to like 5 million caches. I just write to one, which is the popular person's cache. And now if, say, XYZ comes and wants to load their timeline, a few things will happen. Okay, first is the user requests their timeline. The app looks up all the users that this current user XYZ follows, and then it loads the user's cache. Plus it also sees all the popular people that XYZ follows, and then for that correspondingly loads the popular people's cache, popular people's posts from the popular people's cache and gives it to uh, the user. So there are few steps: request, look up the users that this person follows, load their cache, then look up the popular people this person follows, and fetch the popular posts from the popular posts cache. So this way, we are not making joins for the we're not trying to query all the posts for the user like we did previously. And we are also having the popular people's posts without having the popular people's post being written to all their followers cache. So this is like a in between post which handles the popular case well.